this lesson, we're going to talk about the quadratic formula. So if we can solve a quadratic by factoring, then factoring is the way to go, in my opinion. After that, if you can't factor, then you have two other options. You can do the quadratic formula, or you can do completing the square, which we've talked about previously. So the quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. You literally just get your a, your b, and your c, you plug them in, and you simplify. I think this is easier than completing this square, but others may disagree with me on that. If you sing it to the tune of Pop Goes the Weasel, it will help you to remember it. So x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Just kind of makes it catchy for you. So remember that the standard form of a quadratic is ax squared plus bx plus c. So your a is going to be the number with your x squared, your b is going to be the number with x, and your c is going to be the constant. So when you're identifying a, b, and c, it is very important that everything is on one side of the equation and that it's all equal to 0. So I know that a is 3, b is negative 4, and c is negative 9. Now I'm just going to come to my quadratic formula. I'm going to replace all of the b's with negative 4. I'm going to replace the a's with 3, and I'm going to replace c with negative 9. So I have x is equal to negative b, but my b is already negative, so that's going to make this a positive 4 plus or minus the square root of b squared. Now it's very important that you put that in parentheses, especially if you're going to use your calculator, so that you know that negative 4 has to be squared. All right, minus 4 times my a value is 3 times my c value is negative 9 all over 2 times my a value, which is 3. So x equals 4 plus or minus. Now I need to get the number that is underneath that root. So I'm just going to plug in the negative 4 squared minus 4 times 3 times negative 9. Do not put the root in the calculator, especially if you're using a graphing calculator. It's just going to give you a decimal. So the number underneath, all right, which is also known as the discriminant, we'll talk about that later, is 124. And then on the bottom we have 2 times 3 is 6. Now you can do a factor tree to reduce your square root of 124, or you can realize that it's going to split into 4 times 31. 4 is the perfect square, 31 is your prime number, which gives you 2 square roots of 31 all over 6. Now I have a 4, a 2, and a 6. I can reduce all of those by 2, so 4 divided by 2 is 2. 2 square roots of 31 divided by 2 is just the square root of 31, and 6 divided by 2 is 3. So I have x is equal to 2 plus the square root of 31 over 3, and x is equal to 2 minus the square root of 31 over 3. So I have two real answers here, which means if I were to graph this, I would see it cross the x-axis at both of those values. All right, number 2, my a is 1, my b is negative 9, and my c is 27. So x is equal to negative b. My b is already negative, so this will be positive. Plus or minus the square root of b squared, so negative 9 squared. Remember, parentheses are important. Minus 4 times 1 times 27 all over 2 times a, which is 1. So now I have 9 plus or minus the square root of. Now remember, you're just going to plug those numbers in without the square root. You get negative 27 all over 2 times 1, which is 2. Now I already know that because I'm square rooting a negative, I'm going to have an I. And if I want to split this off into a perfect square and a prime number, 27 would be 9 times 3, and the square root of 9 is 3 square roots of 3. Again, if you wanted to do a factor tree to take the guesswork out of that, you can. Now don't forget though that you did square root a negative, so you're going to have an I with that 3. So you have 3i square roots of 3 all over 2. And you cannot reduce the 9, the 3, and the 2. So you have 9 plus 3i square roots of 3 over 2. And then you also have 9 minus 3i square roots of 3 over 2. Now remember, if you have imaginary answers, that means that your graph is never going to cross the x-axis. All right, number 3. Your a value is 2. Your b value is 6. And your c value is 3. So I'm immediately going to plug that into my quadratic formula. X is equal to the negative 6. B is 6, so that would be negative 6. Plus or minus the square root of b squared, so 6 squared, minus 4 times a is 2 times c is 3, all over 2 times a is 2. And then we're going to come up with that discriminant, which is the number that's underneath the root. That's going to give me 12. Oh, I forgot my plus and minus. All over 2 times 2 is 4. Now I need to reduce the square root of 12. I do know that 4 times 3 makes 12. 4 is a perfect square. 3 is a prime number, so I get 2 square roots of 3 all over 4. And then I have negative 6, 2, and 4 will all divide by 2. So negative 6 divided by 2 is negative 3. 2 square roots of 3 divided by 2 is square root of 3. And 4 divided by 2 is 2. So my two answers are negative 3 plus the square root of 3 over 2. And x equals negative 3 minus 3 over, or minus the square root of 3 over 2. On number 4, a is 3, b is negative 2, and c is 7. So I plug into my quadratic formula. X equals negative b. Since b is already negative, that would be a positive 2, plus or minus the square root of b squared, so negative 2 squared, minus 4 times a is 3 times c is 7, all over 2 times a is 3. And then from here, we're just simplifying, so we need to know what that discriminant is. So under the root, I get negative 80. All right, if you split 80 without doing a factor tree, it would be 16 and 5. So I would have 4 square roots of 5. But I don't want to forget that I had a negative. On the bottom, I have a 6. So x equals 2 plus or minus. I'm going to put that I in between the 4 and the square root of 5. So 4i square roots of 5 all over 6. And then I can reduce the 2, the 4, and the 6 by 2. 2 divided by 2 is 1. 4i square root of 5 divided by 2 is 2i square roots of 5. And 6 divided by 2 is 3. So I have two imaginary answers, 1 plus 2i square roots of 5 over 3. And then I also have 1 minus 2i square roots of 5 over 3. So if I were to graph this, it would not cross the x-axis because I have those imaginary solutions. All right, number 5, my a value is 6, my b value is negative 7, and my c value is negative 20. So x is equal to the negative b, which would be positive 7, plus or minus the square root of b squared minus 4 times a is 6 times c is negative 20, all over 2 times a, which is 6. So x equals 7 plus or minus the square root of, and then the number under the root, that discriminant is 529, all over 12. Now, if you do a factor tree for 529, you're going to figure out that it's a perfect square. So if I take the square root of 529, that's going to give me 23. Now, because I can combine 7 and 23, I'm going to split this off into 2. We have 7 plus 23 divided by 12. We also have 7 minus 23 divided by 12. And again, if I do 7 plus 23 divided by 12, I'm going to get 5 over 2. And 7 minus 23 divided by 12 is negative 4/3. When you end up with a single number without a root, so if you end up with something that could be combined, then you could have factored it and maybe done that a little bit easier. All right, number 6 is A is 6, B is 1, and C is negative 15. So x is equal to negative b, that'd be negative 1, plus or minus the square root of b squared minus 4 times a is 6 times c is negative 15, all over 2 times a. So first we're going to figure out what the discriminant is. So if we plug in the 1 squared minus 4 times 6 times negative 15, we get 361 all over 12. 361 is also a perfect square, so if we square root 361, we get 19. And now, since I can combine the negative 1 and the 19, I'm going to split this off into negative 1 plus 19 over 12. And then negative 1 minus 19 over 12. So I end up with 3 over 2 and negative 5 over 3. All right, what values of b, variable b, will cause the equation to have one real solution? Well, I know for it to have one real solution, my discriminant has to be equal to 0. So let's start there. We have a is 2, b is just b, and c is 18. So I know that I have b squared minus 4 times a is 2 times 18, and I want that to equal 0. I'm just trying to figure out what could b to make this equal to 0. Well, if I take the negative 4 times 2 times 18, that's going to give me negative 144. That equals 0. I'm going to solve for b here. So b squared equals, add the 144, and then we'll square root. Don't forget our positive and negative. So if b is positive or negative 12, that means that I'm going to be equal to 0. All right, on number 13, this time we're looking for value or values of b that will cause the equation to have two non-real solutions. So I'm looking for my b squared minus 4ac to equal a negative number. All right, so let's just start with 0, because then I can go from there. So I know that I have b squared minus 4 times a is 5 times c is also 5 equals 0. Now I have b squared minus 100 equals 0. I'm going to add the 100. So b squared equals 100. I will square root. So I have plus or minus 10, because 100 is a perfect square. Now, that would give me one real solution, but I have to figure out, somewhere in the midst of the 10 and the negative 10, I would get negative numbers. So let's think about this. If I had a number that was in between negative 10 and 10, say 0, I could easily plug 0 in for this b and see if that works. Now, if I plug 0 in here, 0 times x is just 0. So now I have 5x squared plus 5 equals 0. If I subtract 5, kind of solve here just to check things out, I would have x squared is equal to negative 1. I would square root that, and then I see that, oh, I'm going to have an I here. So I know that my answers, since I chose 0, is going to have to be between -10 and 10 because that's where 0 is. I could have chosen like 11 and tried 11 and see what kind of answer I would have gotten, or just tried out my discriminant using an 11. So my numbers have to be between those two. I don't want them equal to the -10 and 10 though, because if they're equal to, they would give me 0, and I don't want 0.